disks of the moon inside of the circle Polaris is making.
You can do what?
Fit 2 disks of the moon inside of the circle.
2 moons?
Yes, viewed from Earth,
So you're
obviously.
saying Polaris makes a big circle like 2 moons?
Yeah, a moon
Yeah,
is
he's
half
an
of
idiot.
Can we
the
see
moon
that
is
on
half
He is
of
an idiot.
the
we
moon
see
is
that
half
on
of
some-
degree in diameter, and Polaris makes a circle that is half of degree in radius, so circumference is twice the radius, so twice the moon.
Do we see that on time-lapse photography then?
Yes, obviously, any photography will show you a circle.
If you could show that, that'd be great. I'm not necessarily disagreeing with you, but
Yeah, I didn't know. I didn't know it. I didn't know it was that big of a fucking circle. I didn't know. I didn't know that that's how much it moved. I thought it moved less than that.
Yeah,
I
because
thought it moved so minuscule that you keep it lined up in a fucking pole, and it never moves from the lined up and where you have through that pole lined up looking at it, like never moved. So like,
yeah, because you don't pay attention to it throughout the night. You would have to constantly have fixed eyes looking in the direction to really see it throughout many, many hours.
So when's it gonna move out of my pole?
Your pole.
I got a pole aiming at it, and I stare through the tube at the Polaris. When does it move out of that where I'm staring, out of my sight, out of my shot? I want to shoot it. I got like a pole. I got a sight to it. When does it move out of my sight?
Well, maybe the pole itself already covers too big portion of the sky, so even if it moves, it will always be inside of it.
Yeah, but the pole's diameter isn't as wide as the moon by any means.
How do you know that?
Because it's a little bitty pole. It's little. It's like a little apex tube. It's not that big, brother. It's
Hey.
like 1 inch. I'm just saying.
Demek, I heard that if you take, I heard if you take 2 straws, and they're like a certain distance apart, you look through one, you'll see Polaris. If you look through the other, you won't.
Okay, no, I haven't seen that. Now that would be interesting.
Yeah, I just
Yeah, it'd be super interesting because if that's true and it's supposed to be parallel light rays, that would debunk parallel light rays, would it not?
I just showed a photo taken by one of the Globers on Discord, Seafoam, who is also an astrophotographer, with the stars from Stellarium laid over it to confirm that it is actually Polaris.
Stellarium?
It shows you the constellations, right? So you can match what star this is to confirm this is actually Polaris, not some other star.
So what's it doing?
It's moving around the North Celestial
Pole. He doesn't know what. Hold on a second. He studies the stars, but he doesn't know which star's Polaris. He has to confirm. That's weird.
Yeah, for deniers. This photo is supposed to be addressing the deniers.
Does he need help knowing what the moon is? Or Saturn or Mars?
No, again, for the person taking the photo, it's obvious that it's Polaris, but there are many people denying it, so this is the additional confirmation. Stellarium cannot really be faked.
Hold on a second. Hold on. If you say, Demak, I deny you're taking a picture of a banana, but I'm taking a picture of a banana, it doesn't matter what you deny. It doesn't matter when anybody denies if he's taking a picture, if he's filming Polaris, truly. If I'm filming the moon and you say that's not the real moon, I don't know what to tell you. It's the real moon. That's all I can say, right? I wouldn't go on Stellarium and be like, look, the moon matches this moon. Like that's ridiculous. That doesn't even make no sense.
And here is the raw photo without the labels for comparison.
That's weird. That's just weird that he would have to figure out himself to confirm whether he's even looking at what he thinks he's looking at. That's just odd. If you're said to know the stars, if he's a person, the stargazes, he knows the stars, he looks at them, he records them, he repeats them. He does it every night. He does it over at MMM. I've talked to him a lot of times. He does it all the time. That's weird to me that he would put a telescope anywhere and not know where Polaris is.
Yeah, if
The
you don't like
star.
the photo with labels, he will have a photo
You
without the
can use
labels.
things like the Big Dipper to find Polaris as well.
Right,
Right.
and isn't Polaris supposed to be like a fixed location, and the other stars aren't actually fixed like that? So how would
That's
you
what we're
think?
told.
Yeah, so how would you confuse another star from? I'm not getting it. I don't know. Maybe I'm dumb.
Yeah, again, the point of the label isn't to because the person who took the photo Seafoam was confused what is Polaris is because some of people deny these photos are as fake. They call them fake. So he took this stellarium and overlaid it to confirm that this has to be Polaris for the deniers.
When you guys say photos, don't you have video too?
Yes, there are also videos.
So if there's a video of a star sitting still, it's either it's fake dog shit and it's not real, or he's showing you the real Polaris that's sitting still like Polaris. I mean, I don't understand. I still don't understand.
No, even videos don't show it as still. There is no video like that. When you zoom in, it makes a circle. There are videos that have very wide field of view, cover a very big portion of the sky, so this circle will appear small in these videos, but it still exists there if you zoom in.
Right. I guess I get what you're saying. He just did it for confirmation, but I don't know.
If from just a video or a photo, you can't really tell how big a circle it makes because you don't have any references. You'd need
So why is
additionally
he
an
taking a
info
photo?
of a camera, how big magnification it has, and stuff like that.
Yeah, but you guys think angles mean distance, though, which is weird too. You know.
They don't, but you can convert from one to another using trigonometry. Trigonometry relates angles to physical distances.
You can't convert it without a reference to back
You
your
can.
conversion. You have to have a reference to back your conversion. You
You
can't
have
you can't just say I'm going to get paid for surveying the distance to the sun. Everybody on Earth, everybody on Earth's going to pay you, and you just come up with an answer, and that's just good to go. Someone would have to verify your claim somehow, and it wouldn't just be doing it the same way that you did it. Because if I say 2 + 2 is this, verify. I mean that no, that's not it. This is different than just like adding something on paper. This is a physical attribute of something that you want to know the distance to. So verification would be more physical than mental, right? Anybody can mentally verify or unverify your claim. They can falsify it too, you know. But then at the end of the day, the person that falsified your claim or you have a claim, so both of you could be wrong, both of you could be right, but only one of you can be. Not both of you can at the same time.
uh,
So only
can you
one of you
take?
can be wrong or right, right?
Yes, that's true. Only one thing. If there are two things that contradict, only one can be right.
So which one has been confirmed to be correct over a flat and local sun or the distances of stars versus far out, who knows, billions of light years, calculated, no mechanical proof.
I would say far away is confirmed, at least enough far away where the angular size of the sun doesn't change throughout the day.
You don't know what you don't know what the size of it is. You're guessing that.
No, the angular size. The angular size depends on the distance and the actual size. So
You
if the
don't know.
actual
That's
size,
what you're trying to find out is the distance. Gosh damn, dude. Work with me here, young man. We're trying to
yeah,
confirm whether the distance is correct. So how are you going to do that by saying the distance is correct
Yeah,
already?
yeah.
that's right, brother.
If the physical size stays
Denmark was
constant,
right, homie.
if the physical
Denmark, you may
size
have your
stays constant,
detractors, but sometimes you
I
are
think I
super
give up.
lucid. Yeah, you give up, bro.
Yeah.
So what you're about to say is if the physical size stays constant and the angular size stays constant, then it's got to be far away because of your understanding of perspective. Now, if you claim that, that's fine. You want to put that on the table, then I'll have to bring out the great controversy on the two great world systems where the two dudes argued about I think the Copernican and Ptolemaic model, if I'm not mistaken, in which one guy criticized the other guy that one of the celestial bodies didn't change in angular size when it was in apogee or perigee, and it should have, and it don't. So if you're saying that not changing angular size debunks this claim, then it debunks that claim too. So congratulations, you debunked heliocentrism. Good job.
Which celestial body exactly?
Hell yeah.
Because I'm confident that all of the celestial bodies in the solar system observably change angular size at different portions of the year.
What, like Vega?
Well, I'll tell you what, bro. I'll tell you what. I'll have to get you the book because I'm operating on memory right now.
They say the sun doesn't.
No, it does throughout the year, because throughout the year the Earth gets closer and further from it. But you
Does
have to have a
Mars?
telescope to precisely measure it.
Does Mars?
Can you repeat again?
Does Mars?
Does Mars? Yes, Mars does, even more extremely. That's why it is observed by astronomers only when it's closest, because only there it's enough big in the sky to see the details of it significantly.
You got a measurement of that?
Yeah, there are many photos of that taken.
Photos. Okay.
So how much would the sun have to allegedly change in angular size until your idea that it doesn't change in angular size is no longer valid?
It would depend how big it is and how far away it gets. I mean, how far away it gets would just be based on the distance between some cities on the Earth, or it's in zenith at different moments.
Yeah. So if I take my thumb in front of my face, it's one angular size. And if I put it on the wall across the room, it's another angular size. If I ask my friend to be my thumb, and then I go to the other side of the room and see his thumb, if he then transposes from one side of the room to the other, in my field of view, his thumb will barely change angular size at all, even though it's a fixed distance, right? Roughly.
When it's fixed distance, then the angular size will still stay constant.
Yeah, but you would agree that the corners of the room are a further distance, right?
The corners of the room.
Yeah. Yep. So the center of a room and the corners of the room are diagonal, so they're a greater distance from you, right?
Where you would be standing, exactly?
On the other side of the room in the center.
Oh, on the other side.
No.
Wait a moment. Yeah, that's true. That's true. They would have different distances. If the room
Right.
is,
So what I'm asking you is, there's always this claim: the sun doesn't change in angular size, therefore the Earth can't be flat. There's that claim floating out there. Now, do you agree with that claim?
Yes.
For those reasons?
Yeah, I agree that. Yeah, because you need the sun to be moving away to explain things like day and night, for example. So if you assume the sun is far away, then the day and night already would debunk flat Earth.
Really? What? How so?
Because all of the places on the Earth would see the sun fairly high in the sky. It wouldn't set due to perspective because it would have to be closer to do that.
Why? Why would it have to be closer to set? That doesn't make no sense. Wouldn't it have to be farther?
I mean, it would have to be closer in altitude.
Closer to what?
Yeah, so if
That's
the
what I
sun
mean.
is,
Like, you don't know. You actually don't know any of these numbers, do you?
I mean, I could calculate how much of angular size change would there be between some cities, for example, based on the distance between them?
But if Earth is close and local and it's flat, you're trying to say Earth is far away and it's flat. You're trying to say Earth's the sun is millions of miles away and it's flat and the sun's shining so hard and so good and shining over the whole fucking everything. But I just don't think the sun's that badass. And number two, if it's close and local, the sun is close and local over the flat Earth, then what you're saying is not going to work out either way. Because then it would be close and local and it still wouldn't light up the whole Earth. So if it's closer and not lighting up the whole Earth, why would it be farther away light up the whole Earth?
Well, I think that's a good point actually when I think about how big it would change in angular size would depend on how high it is. Because if the sun was very, very, very high, and it would get, like, let's say, from above Australia to above, I don't know, South America, then it would barely change the angular size. But if it was...
perfect. I agree with you. Now, flip the room with the guy with the thumb on its side. So when he moves his thumb, he's going up and down. And as he moves his thumb up and down, it's either higher or lower, right? But
Yes.
it's still the same angular relationship, right?
Yes.
Okay. So, if you take the Rayleigh atmosphere thing at 350 miles, it's opaque atmosphere. Right? So essentially, at 350 miles, you have a wall of atmosphere that you can't see through that wanes off diagonally. So eventually, there'll be a diagonal in which you can see something greater than 350. So what if the sun's hiding behind that opaque wall of atmosphere at a low enough angle in your field of view that's occupied by the position of the hypotenuse of the triangle relative to its distance, and that is greater than your ability to see through that opaqueness, but not greater than its ability to change dramatically in angular size before it disappears.
Sun's perspective. Yep.
I don't really think that would make sense, because we can observe things that are actually disappearing because of the atmosphere, like mountains, for example, and they don't disappear behind the horizon because of it. They just fade into the sky before they reach the horizon. And the sun never does that because it is so bright that even when it's very, very low above the horizon, so in a place where the attenuation of light is the strongest, it will still not vanish in the middle of the sky. And you actually can use the sun as a reference.
Boy.
What?
I will eat you.
No, you won't. Carry on, buddy.
Yeah, you can actually use the sun to bring these objects that disappeared behind the atmosphere back, like the mountains. Firstly, they are merged with the sky, and then the sunset, you can calculate what azimuth the sunset will be at and align yourself. And it brings
You mean like the one... Yeah, I agree with you.
Like so the Canigou, for example.
So like when Jaren did that one mountain at a particular time of day that the other guy did, and it's silhouetted, but it should have been below like miles and miles and miles of hidden curvature, but yet it's silhouetted. So how did we see it, homie?
I don't think it should be, really. Behind miles of
Here's the problem, dude. You say that the sun can silhouette a mountain, right? And then you see a silhouette of a mountain that geometrically is orders of magnitudes impossible to see if there's a giant hump of Earth curve, and then all of a sudden it's kind of like whoop-de-doo. Like that claim don't really matter anymore?
I just don't think this geometrically is what you wouldn't expect on the globe, because I already saw that observation and I did the math. It was like already a couple months ago, and it kind of matched. And not only it matched, the mountain the island, I mean, was the very, very tip of the island. It wasn't actually the island. It was just the very tip of it.
I don't think you're talking about the same one, dude.
It was like an infrared.
But we all know the truth.
From California, I think.
Yeah, that's fair, dude. It's fair, but we all know the truth. Dude, we all know the truth. If we show you an object that's hundreds of miles away, that's supposed to be below miles and miles of curvature, you'll just make an excuse that the wonkily donkily light, right? That's what you'll say every single time. So why even entertain these things? Because we know that your claim is that the globe's unfalsifiable optically, and you need it to be so. Because if it wasn't, then it would be falsified already.
No, it really isn't. The reason why it isn't is because you cannot calculate how big of something you would see on the globe based on refraction on atmospheric conditions, and if this is still too much for the conditions
You're
you
wrong,
calculated,
sir.
then
You're
it
wrong.
would be.
You're wrong, dude. You're wrong. There's
How am I
there's
wrong?
no quantification because there's no quantification of any physical refraction that can supersede these observations. It's always just put into a calculator where it calculates how much refraction you would need, and then you just claim that's the refraction that exists. And we all know we've experienced Globers doing this. Even Walter Bislin, his dumb self, did it, dude.
No, I disagree. Walter Bislin actually has formulas on his website where refraction is calculated based on the conditions, not on what you see.
No, dude, you're wrong.
He actually has
That's
this
the problem.
formulas.
You think that's the truth. Yes, but they don't account for all the observations, dude. That's the
They
point. The
do.
extreme observations they don't account for, and he just makes up a refractive index that don't exist.
Yeah, I would say that it does for all of the observations that were made where there were meteorological stations to measure conditions. In places where there was no measurements, it obviously wouldn't because you don't know the conditions. But then it wouldn't be for flat Earth. It would be just inconclusive.
Okay, that's
Because you
cool.
don't know the
So
conditions.
okay, so if you have if you have the ability to tell me what the refractive conditions are and how much they're going to arc the light, then that means you can tell me exactly that, so we can take a laser and do a laser transit and figure out if the Earth is curved or not. Yes or no?
Yes, but you would need to either do it in a place where there's a weather station to measure it for you or to measure it yourself.
Okay, so if Field Engineer Corps got the data from two weather stations and extrapolated out the ambient refraction and then did a laser test, why do you deny the results?
I don't deny any results. I don't know what exact measurement you're talking about.
Yeah. We're talking about the FE Corps 25-mile laser shot at Lake Itzel, dude.
Oh, yeah, they made an error because they assumed that refraction is due to horizontal gradient, not accounting for the vertical gradient in the atmosphere. And because they had no significant horizontal gradient, they assumed the refraction can be neglected at all.
Oh, really? So where is that in their document?
Let me find it.
And what do you mean by horizontal gradient versus vertical gradient? Because that's kind of like you got to parse that out.
So refraction
Like a
is
horizontal
mainly based.
gradient.
Yeah, refraction is mainly based not only based by but this is the greatest factor on the lapse rate of the temperature. So how fast the temperature changes with height. But they assumed that the only thing that influences it is how much the temperature would change like horizontally. So I'm in like one side of the lake and someone else is on other side of the lake on the same elevation, and they measure how big change of temperature there is, and they noticed no significant change, and they say because of that there's no refraction, but they didn't account for the vertical change with elevation, which is actually the main factor.
Oh, really? So why don't you tell us what the vertical change would be so we can redo the Lake Edgefield test and then get it correct?
I mean, do you want me to reverse engineer how big lapse rate you would need for this observation?
Well, that seems to be the trend with Globers is you have an observation and they just reverse engineer it and then say, voila, that's exactly what it happened. So yeah, that should be what you do, I imagine.
Even if there are people like that, I'm not one of those people personally.
Yeah, what we're asking you for is what we want, dude, is the accurate refraction model so that we can know what the laser's supposed to be doing, so that we can use a laser transit to either prove or disprove that there's curve there. So if you have that accurate refraction model that makes predictions, go ahead, let us have it.
Yeah, I already told you that in on Walter Bieslin's website.
Does it make predictions? Does it?
Yeah, it makes predictions.
Yeah, sure thing, buddy. That's why he couldn't predict the black swan, and he had to retro-engineer the ray paths, and he ended up crisscrossing them before the optic, which would make the image appear upside down. Yet the image isn't upside down in the black swan, so Walter Bislin's a moron.
Yeah, but the flat earthers there, I mean, the one flat earther that took the photo didn't care about measuring the conditions, so there's really no other.
No, you don't seem to understand, dude. The only way Bislin could accurately model that is he had to invert the rays before the optic in his model. That would make the rays appear upside down. Okay, that would make part of the image upside down, yet none of the image is upside down.
But it is true? I didn't know about that personally.
Oh yeah, maybe you should look at his little sideways model of it, dude, where he modeled the rays. What he did is he just retro-engineers the path that he thinks the light would have to take to get that, but he screwed up by inverting them.
Do you have the link to the FE Core PDF? Because I can't find it, even though I'm looking for the videos analyzing it. They don't link it in the description for some reason.
The easiest way to find it is either someone get it for you, or you just go to 24/7 and search it up, and just search FE Core PDF, and it'll come right up.
Give me
I
2
am
seconds.
banned there,
I'll find
and even if I wasn't, then I wouldn't be able to join because I have the server limit. I already have 100 servers, and I cannot join more because of this server limit.
Point. Good point.
I'll find it. I'll find it. No worries for you.
Well, stop. Listen, cancel your subscriptions to all the degenerate Entei servers and make some room for the best 24/7 flat Earth server there is.
But I'm banned there.
What? Oh my goodness, dude! Why is everybody banned?
Ask India.
Well, maybe he asked you for the accurate model of refraction, and then you couldn't give it to him, and you said it exists but couldn't give it, and then he said, "Okay, I'm sick of you," and then banned you. That's probably what happened.
No, it wasn't India. It was some other guy, and it was about spectroscopy. He was saying that lights in the sky, we cannot know anything about them, and then I say that spectroscopy is literally doing that from definition, and he rage quit and banned me because of that.
Oh, what was his name? What was his name, dude?
I don't remember. It was a very long time ago.
Wait, which room was this?
Which server?
Yeah.
24/7 Flat Earth.
Oh, this one.
No,
Oh, this
not
is like
this
a
one.
colony
This is
of
the
it.
politics server.
A colony, I'd rather an embassy.
God.
This voice channel is a colony of an entire separate server.
What I'm telling you is that I would rather call it an embassy.
Okay, well done.
Yeah, it's actually a satellite.
Oh, that's even better. You win.
I know. I usually
Ember,
do.
I'll put the PDF in the chat for you.
I'm gonna steal that.
I used to troll people, and I tell them, "Dude, I've been in a satellite before." And they're like, "What? How did you get up to space?" And I'm like, "Dude, I just went to a branch of my bank. That's not the main branch. That's a satellite branch."
What a Sigma.
And then they're like, "Dang, dude." I'm like, "Yeah, it's not my fault. You got a limited vocabulary."
Damn. Wait, how do you feel about like the rule of completeness?
Well, if it's complete, then it would be complete, and then it would possess completeness, and therefore it would be complete. So, I mean, I guess that sounds nice.
No, it's the idea that if one party introduces one thing, like part of a rating or part of a recorded statement, an adverse party at any time can ask for the full context. Is that like a fair
that's
standard?
Yeah, to a degree. So, for example, sometimes we do 8-hour episodes. So, if you said, let's review the full context, and we had to sit here for 8 hours.
Well, I think the standard is that the context would itself be substantive. Like in fairness, the context ought be considered at the same time.
Absolutely. In fact, it behooves people to call other people out when they think there's an incomplete context. To just let it slide that the other guy's making a point that actually is relevant, isolated from the context. You shouldn't just assume that. You should be like, hey, what's the greater context in which that was said?
How do you feel about adjudicative fact?
Wait a minute, dude. We don't do racial slurs here, so stop asking if a adjudicata effect.
No, it's like adjudicative. How do you pronounce it? Hold on, let me Google it. Maybe I said it wrong. Well, that was adjudicative, but maybe I'm wrong.
Yeah, it means that when both parties agree to a fact of a case. Like,
how do you say the word is the question.
Adjudicate.
No, the
adjudicate.
The participle form.
Adjudicative.
It's adjudicative. Okay,
like
what's
both,
the IPAY?
Like you could say both of us agree that Earth, uppercase E, means where we live, and lowercase E.
Yeah, it's adjudicative. Adjudicative. Yeah.
Like
generally the standard is what's interesting is the standard is like things that are generally known, or things that
just in context of the one conversation.
Well, there's a stipulation, right? Or there's a requirement that for a fact to be noticed, it has to be generally known or be accurately and readily determined from sources whose accuracy cannot be reasonably questioned. How do you feel about the second standard? Like, does that make sense?
Yeah, it has to be agreed to by both sides. This is why Flat Earth won 3 times in court.
Because the globe Earth cannot be accurately and readily determined from sources whose accuracy cannot be reasonably questioned.
And everything they have.
Yeah.
Yeah, it's all flat Earth proof. What they use for anything they have.
What's the difference between like the burden of persuasion and the burden of proof? What does that even mean?
Persuasion isn't proof. Persuasion is just talking.
Well, what's the burden of persuasion?
I don't know. Sounds pretty weird.
I don't know, dude. If the other guy agrees with you, right, then you persuaded him, right?
Yes, sir.
It's self-fulfilling, I guess.
Yeah, that's why. Like sometimes yes means no. You gotta be careful. The legalese of a lot of these things can parse out things that you did not agree to, but because it sounded good, now you're like fucking up shit creek.
Right.
Oh, it makes sense. So burden of persuasion is the fact that your evidence has to be compelling. And then the burden of production is your obligation to come forward with sufficient evidence. And then those two constitute the burden of proof. I think.
Yeah, I like the burden of production. That's a good one.
Wait, is burden of proof strictly a legal term? Because I hear it used casually a lot.
Burden of proof is just on the person who makes the claim, right?
No.
No.
Or rather, that's not quite right.
Sorry,
no, it depends on in legal it depends on what law it is. I'm trying to think of a good example. Like in a traffic citation, you have the burden of proof to prove it wasn't you. Where in a criminal case or like other cases, the state has to prove it was you. So
what's even more interesting is like Title IX.
On the blank on the word for that, but it's like affirmative and non-affirmative defense.
But if somebody comes in here and they make a claim, it's the burden is not upon me to prove their claim. The burden is upon them to demonstrate that that claim is true. In here.
Yes.
Oh, it makes sense. Burden of production has nothing to do with the jury. It is a matter of law, and it's what can be looked at on appeal. Burden of persuasion pertains to the jury.
Yeah, so speaking of that, where's the accurate model of predictive refraction, of which you can tell me what the refractive conditions are based on the observation, that I can reverse engineer to shoot a laser and accurately do a laser transit, discover.
What's interesting is that sure. What's interesting that is if all of these refraction models weren't at least somewhat close to the truth, then like water in video games, glass in video games, glass in CGI, it would all look terrible. But it seems like it looks pretty good. So I would imagine our models are somewhat close.
Wow, dude, that's hot.
No, I mean like any semi-transparent surface has like an IOR. And it seems like if it was drastically wrong, you would just look at any CGI and be like, that doesn't make sense.
Okay.
Like think about like the Fresnel effect.
Video games. Yes. Yeah. You're saying video games have refraction. That's what you're trying to say.
What I'm saying is that if our models were so disastrously wrong, then you'd be able to look at any CGI film and instantly know this is bullshit. But like you can't.
Yeah, they are.
What the hell are you talking about?
Yeah, you can.
You can. No, I don't think so. Because
basically the same thing with Musk. Musk's defense of why Starman was so bad is that there's better CGI.
Oh, I mean, I agree. There's variance in CGI, but like insofar as like the physically based rendering, it seems like
that's a cool story. I don't care. I'm talking about reality, bro. The reality. What I'm saying is that
have you ever watched a movie? Those exist in reality, surely. Have you seen a movie ever?
Yeah, that's cool. So in reality,
have you ever seen a movie? No, but like if you've ever looked at a movie and you look at CGI,
right, so what you're basically saying is people can make convincing artwork. Therefore, what?
Well, what I'm telling you is it's physically based rendering, right? So it uses the same models of reality that the physicists propose. And if those models of reality weren't good enough, or if they were disastrously wrong, then the results you see on screen would be terrible. But it seems like they're somewhat close.
What are you on about?
What I mean is that for water especially...
Therefore refraction. That's
what I'm telling you is that good water looks good because of good refraction. I don't understand how we could even get remotely good water if we didn't have a model of refraction that was somewhat close.
Yep. But
what are you talking about, dude? When you're looking at when you're in the ambient atmosphere looking into water, that's a dual medium boundary.
That's Snell's law.
No, but what's interesting, Snell's law, but also the Fresnel effect. The fact that we can get that precisely right with CGI seems to indicate that our laws of optics are somewhat close.
Get what right? What do you?
Yes, that was low. Yeah.
For the Fresnel effect.
Yeah. Yeah. Why don't you explain for the audience who doesn't know what that is? Okay.
Sure. So the Fresnel effect is is a property of refraction, wherein if you look at a water, when it's close to you, it's more refractive than when it is further away. And the effect of that is that when you look straight into the water, you can see a little bit of the ocean, but then as you get further out, or suppose it's like a flat pool, you can actually see directly down. But you can. It's hard to just. Let me get a picture. Can I see a picture?
Right. So this is two media discrete boundary refraction you're talking about, dude. It's not what we're talking about.
Well, you don't even know what I'm talking about, so let me get you a video.
Oh, my goodness, dude. No, yeah, dude.
Okay,
You're talking about one media giving way to another media at different ranges.
No, but do you see it? Look inside, chat. You notice how you can see like it below the camera, but not further out? That's called the Fresnel effect.
Wow.
What's interesting is if you actually go out into the world, it looks just like that. Oh, here's a better example. This is another Fresnel effect.
Yeah, yeah, full story. That's a single boundary, for goodness sakes.
Well, what I'm telling you is that it also applies to cafeteria room floors and hallways, which is interesting.
Holy crap. Yeah, that's reflection.
Dude, is this guy even listening to you, AI? I think you said it about 2 or 3 times. Seems not to catch on.
Well, I mean,
yeah.
To be fair, I'm attempting to be accommodating to his disability.
Well, let him be accommodating. Let him be patient.
For those of you guys who don't know Ree's kind of a sophist intellectual gamer. So what you're gonna get is your classic obfuscation tactics, reduction to absurdity tactics. Let's see. There's a couple of other things, but needless to say, the overuse of the word gamer. Hold on a second, Ree. Needless to say, the overuse of the word gamer will be utilized in the conversation colloquially with that person, and also the individual will attempt to, at best, make it seem like every argument is riddled with nuanced categories. So, just for you guys, that's what it is. So
the Fresnel effect is a special case of Snell's law, which someone else mentioned, but I think it's the most interesting case because I can send pretty pictures from the real world.
Yeah, and also identifying that the gaming world is the same as the real world. So, added to.
What's interesting is that if
but it doesn't matter, dude. It doesn't matter because this is talking about a discrete media boundary. For goodness sakes, that is not what Globers are using as a retort to supersediary observations that debunk globe geometry by orders of magnitude. They're not attempting to say there's a discrete boundary. For goodness sakes.
Discrete boundary between what and what?
Doesn't even apply.
Sorry, the boundaries between what and what?
2 different mediums.
Okay, in the game, dude, the surface of the water is a discrete boundary between the airspace of the game and the water of the game, correct?
No, I agree. The Snell's law is because the two media have different refractive indices.
There's a boundary between the two.
Well, I mean, this also applies in a continuously varying substance. So it's not about the boundary; it's just about the difference.
Cool. You know, how do you preserve the normal line in a continuous variable media?
The normal line? What is the normal line? What is that? Like the regular line, the typical line?
No, normal.
What's that?
Oh my goodness, dude! That's how you get the angle of incidence and the angle of refraction. They're off the normal line.
What does that mean?
Oh my goodness!
It's the line that's perpendicular to the surface of the boundary between the two mediums. So if you have a pane of glass, right? Was that it, or did I miss?
But how does that? But so, like, what you're saying is there's this perpendicular vector.
Yeah,
how does that relate to this refraction?
So if you have a pane of glass, right? There's an index of a specific index between glass and air.
Yeah.
So it's a flat plane. The normal line is a 90-degree angle from that flat plane, like just to keep it simple. So if you shine light on it at like a 45-degree angle, there's some relationship between that angle, the 45-degree, and the pane of glass, and that normal line, which is which is used to calculate or to infer what that index is as it bends inside the glass or refracts inside the glass. So simply put, it's a perpendicular line to the boundary of the two medium.
Well, how do you think you're getting your angles?
Oh, is the hold on, to be clear, is the claim that the dot product? Or, sorry, I'll just be simple. The angle between the normal vector and the line of incidence, or sorry, the ray of incidence. What do you call the incoming ray and the outgoing ray? What's the terminology? I just want to be correct here. Do you know?
I wouldn't know.
I'll just call it incoming and outgoing, but I'll call it incoming and reflected, actually. Yeah, the angle between the incoming ray and the normal vector is going to be the same angle between the outgoing ray or the reflected ray and the normal vector. That's the law of reflection.
Ray and the
That's the first law of reflection.
Yeah, incident ray and refracted ray. And how do you think you're going to get those angles? You're going to use the normal line and the path of light.
I mean, the one... I mean, the actual law is in terms of the dot product, but what's your question?
It's because not all surfaces are perfectly flat, right? So if you take a tangent to a curved surface, you can compute a
that's correct. Yeah,
line from the tangent, right? That's why it's important.
Most surfaces aren't flat.
That's why it's important to get so you can actually do proper calculations.
I agree. I think everything you've been saying is correct, but is there any disagreement?
This is where the disagreement is. Okay, the fact that you need... Oh, go ahead, Jedi. I'm sorry. Take it away.
No, sorry, mate. I do apologise. The point to this is we're talking about how refraction works when you pass from one medium to another and the instance of the light hitting that boundary. Now, how's that comparable to having no line of instance in one medium? Just refraction through a gas where there's no boundary, which is what AI was trying to point out. There's no angle of incidence. There's no physical separation between one medium and another.
It's interesting to be clear, it's interesting that when a ray refracts, it splits into two rays, correct?
What causes refraction, Dave? We've just been through this.
Which is correct. When a single ray hits a refractive plane, it splits up into two rays after that point, right?
That's who? Says who, bro? That's not true.
Do we agree or disagree there?
I mean, it would only if you have total internal reflection, but if you don't have it, then you would only have one ray.
Well, it depends on what you mean by ray. Are you saying a monochromatic ray? Are you saying a single photon stream? I mean, what are you talking about here?
I'm trying to figure out like which law this is, so I can get you the Wikipedia.
Yeah, what's a ray? That we're trying to decide what a ray is.
A ray is you can think of it as a particle with a direction that is moving.
He asked you what a ray was, not what we think of what a ray is.
No,
what is a ray?
Okay, so just hold on. If a ray is a singular particle with a direction, then how could it possibly split into two of those things when it's only one particle?
Well, that's because of refraction. That's the definition of refraction.
So you answered your own question.
No, because the rays aren't. No, you can split rays. You can split atoms, right? These aren't special. What are you talking about?
Holy fuck! Split atoms.
Holy shit, dude! So when something refracts, you split an atom and you get an atomic explosion. Holy crap!
No, but what I'm saying is that these physical quantities aren't. It's not surprising that we can split physical quantities.
Have you ever seen a ray split?
Have you ever seen a prism? Dude, hold on a second. I just got to say this joke. Have you ever seen a prism go nuclear when you shine light through it? Take off the ether board.
This is kind of boring, though.
Yeah,
it's very good, but we're just being tongue-in-cheek silly with you, dude, because you made a faux pas, all right? No big deal. It's all right.
Do we disagree that one incoming ray would have two reflected rays when there's refraction?
In the room, Ree. You're not the only person. So you just said that a ray of light can split. Do you have any evidence? Do you have any evidence?
Side chat.
No, I want you to tell me. Use your words. Can you do that?
I took a picture and I put it in side chat. Can you go look at that?
And you use your words how it happens. How does that happen?
Hold on. Do we disagree that this does happen, or are we asking why it happens?
Can you just tell?
That's not a ray.
Dude, listen. It's simple, right? Can you just tell to us how you know that a ray can split in half? How does it happen? What is the method by which we can discover this occurs? Simple.
Sorry, how is this relevant?
Because you said you know that it happens. I want to know.
I know that it happens because I just did it and I took a picture and put it inside chat.
You did it.
Why
Okay,
it happens is interesting.
How did you do it? How did you do it?
Sure, I shined a beam at a refractive medium, and then I took a picture of it and I put it inside.
A beam of what? A flashlight? A laser beam? What are you shining?
Well, before he goes on, by his definition of what a ray is, this is not demonstrating a split ray. He changed it to beam for this example.
Yeah.
So beam and a ray would be two different things. A beam would be a continuous stream of photons, right? Whereas a ray could be described as a singular photon on its path.
What I'm telling you is that a beam is a set of rays.
Okay.
Right.
Yeah,
So
but
the
you
ray's
haven't
not
defined.
splitting
Listen,
that.
yeah, you haven't. First, and I was gonna make my point earlier. You haven't defined what a ray is.
I just
What
did.
is a ray?
Someone in this call just said your definition, so clearly I gave one.
And use your words to tell me what a ray is. You're super verbose, but in this particular matter, you're not. That's
no,
weird.
I think it's a particle moving along a direction.
You think? Why are you suggestive now? How come there's no defined way of you telling me what a ray is? That's interesting.
Wait, do you not think a ray is that?
I'm not talking about what I think. What is the defined
Wait, then
meaning
why are
of
you
a ray?
asking? Wait, why are you asking?
Because you're not giving the defined meaning of a ray, and you're dancing around the fact that you don't know it.
The defined meaning of a ray? What does that even mean?
What is the definition? You imbecile.
English is English your first language?
I just gave the definition. The definition
No,
is
you
it's a
didn't. You said
particle.
this is what I think.
A
What I think
particle.
is suggestive.
A ray
I don't
is a
care about what you
particle.
think.
A ray is a particle moving in a direction.
Okay, how have we discovered that this occurs? Like, what's the measurement for this?
I just did it and took a picture and I
No,
put it
you
inside
just
chat.
did it. You didn't just do anything.
I did. In fact, I put inside chat the
Then
picture.
you'd be able to tell me. Use your words. You're verbose. You can use your words. How you've done that? How did you see a ray?
I shown a set of rays at a refractive
A set
medium.
of rays. Okay, no, we're talking about just a ray. We're not talking about a set of rays. A ray. A ray.
Well, because of wave-particle duality, there's no such thing as a single ray.
Because of wave-particle duality is not the answer, is it?
What I'm telling you
Not
is
the one
that
I'm
there's no
looking
such
for.
thing as a single ray. That doesn't exist.
Well, then why are you using it?
I'm using a beam, which is a set of rays.
Okay, but you don't know what a ray is, and you just said you took a picture
So
of
a
one.
ray
didn't
is
you?
a particle moving along a direction.
And you've never seen one, have you?
Well, rays don't exist.
And they don't exist. Then why are we talking about something that don't exist?
Well, squares don't exist. The number 2 doesn't exist, but it seems to be useful when we talk about reality to understand
you know
what a square
that
is.
your answer is so discombobulated from reality, and you don't know how to answer because right now
Wait,
you're
do you think
struggling to
squares are
figure out-
real? Wait, hold on. Do you think
know what's
squares are
weird?
real? Do you think the number 2
You
is
know what-
real?
yeah, hold on. Let me just give you an assessment of what's going on. The
Do you think
assessment
the
is.
number 5 exists? Are you crazy?
Hold on a second. Don't get your undies in a bunch. Your undies are in a bunch right now. Relax.
You think that circles are real?
But
Yeah, just
I
relax.
want to have 2 rodeo burgers.
Dude, you just
Yeah.
Yeah, you're ordering
And-
Burger King, brother.
You know what?
Yeah, somebody needs.
Wait,
Or
seriously,
like
you think
Wilbur's
circles are real?
That thing where
We're not talking about if circles are real.
Wait, you think circles are real though, don't you?
Reed. You know what? Your diversion tactics, I'm immune to them. I don't have to listen to you talk bullshit. So here's what's going to happen.
It's not surprising me that abstract mathematical concepts are real.
Look, I'm stepping on your big toe right now. You think that I can't do that? I am doing that. People are realizing that even your verbose language is not going to help you here. You're not going to get away. You're being held down to the point that you don't know what a ray is.
Choked out in a sexual way, but go on.
Yeah. And it seems like you don't understand when that's happening to you, but my friend, it's happening right now.
Sorry, what? Can you just
don't know
make your
what a ray
point?
is.
What
Yeah,
are you
I know.
saying?
I like to put a little piece of flair to what I'm doing to you, right? Because you're a special case.
You're very flamboyant. But what's your point?
Yeah, I am, because I need to be. It's with special cases like you. So here's the thing.
I'm very special.
You
My
didn't
parents tell me
describe.
that.
You didn't describe. Yep. Go on and interrupt me. You didn't describe what a ray is. You didn't define it.
No, I gave you that. A ray is a particle moving in a direction. Did you not hear?
Yeah, have you
But
seen
you understand that a ray is a particle
you
moving in a
seen one?
direction, correct?
Tell me, have you seen it?
Do you accept that a ray is a particle moving in a direction? Do you at least accept that?
I'm not accepting your fucking version of a ray. If you defined it, then I'm asking you now, have you ever seen one?
Rays don't exist in the same way that squares don't exist or circles don't exist or the number 2 doesn't exist.
So now that rays don't exist, how do you see one?
He's defined it as a particle moving in a straight path, and then at the other side of his mouth, he said it doesn't exist.
Yeah. How do you see something that doesn't exist, Ree?
Isn't it? They're just redefining the concept.
Because there's only a particle at intervals of time. The motion of it together doesn't exist.
Says you, but it doesn't exist.
In fact, in fact, depending on how you go on.
How do you listen? This is what's confusing for the audience. Maybe.
Well, like lines don't exist.
How are you in here?
Squares don't exist.
Yeah, I know. So you're just defeating. You're shooting yourself in the face, dude.
Wait, but you understand that you talk about spheres all the time, yet you recognize they don't exist.
Okay, so
this diversion tactic doesn't work on me, Ree.
No, but your point is that what I'm talking about doesn't exist, therefore it's irrelevant. But all mathematical concepts don't exist, but we talk about math all the time in this call.
Going back to the point that you were in here talking about all things Ray. Then when we came to the point where you're now going to
a ray is a model of reality, but they don't exist.
Why do you have to interrupt me, Ray? Why? So when we're now talking about what a ray is, as a defined way, what we know it is, you say it doesn't exist. Now, the whole point that you had was you're trying to tell us what you can see, what you can test. Oh, it's in the chat. Check it out. And then I'm asking you, well, you've never seen one, so how do you know what it does? Now we're back to where we started from in the beginning. You're coming up with something you have no clue what you're talking about, and that's what's going on. And I don't know why you think it's important.
Wait, do you think squares exist? Why won't you answer that?
I don't know why you think it's important for you to multiply your words right now. I really don't. You're not making any sense.
Globe evidence, guy. Where's the globe evidence at? You're just waffling.
Well, it's not an array of light. It's not.
You understand that lines don't exist, right?
You understand that you saying lines don't exist and talking about conceptual rays is not evidence that you live on a spinning ball, right?
No, I'm a flat earther. I don't believe in the spinning ball. But insofar as laws of refraction,
oh my God.
No, you're not.
I'm a Snell enjoyer when it comes to refraction.
Why do you not believe the world's a globe then?
I don't know. Should we just keep entertaining the attention seeker?
Yeah, I'll keep smashing the attention seeker every single time that person.
I think he wasn't arguing for the globe the whole time.
Yeah, I'd like to think it'd be very entertaining to hear them trying to reconcile this ray beam thing.
No, wasting your time.
Oh, we got to the ray beam thing.
Well, because he was saying that a ray of light will split, but then defines as being a single particle of light, single photon. Yeah.
What's he talking about?
So and then he says it doesn't exist.
Yeah,
so how do you have something that doesn't exist? And even if it does exist,
speaking about that nonsense, what's the point in that? Get someone who's actually going to discuss the Earth. And he's either lying about being a flat earther or he's just wasting time. Either way.
I thought it'd be funny to hear him fumble, but go ahead.
Yeah, just how blatant dishonesty is mutable. So if he's in here LARPing as a flat earther, just get the fuck out.
He's a liar.
Yeah.
Hey, Ree, gotcha, bitch.
Fucking clown.
You snatched that wig.
Isn't there a semi-normal Glooby in? Surely.
Hopefully, Ree will think twice opening up his incoherent pie hole.
I mean, it seems like beams of light act like rays. They're good models.
Look at him. Who cares? What are you talking about? Rays and beams of light.
Gotcha.
Is that a better definition?
Just do a hard reset.
Yeah, he did. We could always move on to Blueprint. He's very active up and down in the side chat. We could always move on to Blueprint if we want.
Yep. The big gods die here, Ree.
You got the docs. You got the globe.
I don't know.
You got the documents for the globe.
I think you're right. I'm happy to. I think what I did poorly rhetorically was just not have a strong definition immediately because I didn't think I'd get.
You tried to LARP.
Well, no, I mean of the geometry. I think I should have just embraced that and gone fully autistic mode.
Yeah, embrace CL as well.
That is what you did. You went fully autistic over concepts. It's a very globe behavior. So who's
right? I mean, I was a glober up until a few days ago, so it makes sense.
What made you change your mind?
I realized that gas needs containment.
Okay. Fair enough. There you go.
The Earth is flat.
Isn't that Jedi's agreement?
I still believe in the Snow laws.
It still doesn't. The Earth is flat.
Why would gas needing containment make the Earth flat?
Yeah, exactly.
Because it completely puts a wrench in the globe cosmology, and the only sensible model after that is the flat Earth.
What if you're in a Dyson sphere?
But that's not parsimonious, right? I think this fails to Occam's razor.
Who cares?
Well, Occam's razor is something I commit myself to.
What if a million years ago humanity was going extinct because of plastic straws, and so we had to travel to a new location in the universe by constructing a barrier around our world and then jettisoning it out with a huge nuclear explosion towards the great frontier?
Yeah, this just fails to Occam's razor. It just makes so much more sense. It's so much more simple and parsimonious for the Earth to be flat.
Yeah,
but introduce Dyson spheres and like all this psycho mumbo jumbo, but like we just need to think about the Earth as a flat plane.
A logical framework to look at this the way that you should. It's not just because of gas pressure. It's not it. That's not going
to. Well, let's be clear. That's like the straw that broke the camel's back, I think.
Well, that'd be different.
Can I ask you a question? If this is the case, how come not 2 minutes ago you were arguing for a phenomena that is in support of the globe model, i.e. refraction through a single medium, just via interaction with fluctuations in other variables?
No, because I've written a ray tracer in a college class, and I did this math, and I think it's good. I think it models reality well.
Well, again, if this has to do with refraction through several mediums, I don't think anybody's arguing that. That's not in contention. So
the claim that I made that people took issue with was about a single incoming ray having two outgoing rays when there's refraction.
No, that wasn't it. That wasn't even it. That wasn't even it.
You're changing.
What claim do you think I made that people took issue with?
You don't even understand what a ray is to have some kind of understanding to give us about what you think it's doing.
Well,
you see the problem here? You know the problem? That's the problem. You're going at this specific model and saying there be reality. That's not it. We're looking at how you think because you're analyzing the information based upon some information that's been given to you, from academia. And then we're telling you, well, from the basis of that, how do you know what it is? How did you identify that? What's the method?
It just seems
now
weird as well that...
Yeah, go ahead.
Sorry. Well, no, I was just going to say, it just seems weird as well that you're saying, like, you've just recently figured out that the Earth isn't a giant spinning ball because of gas pressure, but, like, the thing you mainly want to discuss is your notion of what a ray is and whether it splits in two. Like, surely you'd be more thinking about the bigger picture here. Like, if you've just realized the Earth isn't a spinning ball, why are you being autistic about rays?
What makes the ray split?
I mean, it seems like, to be clear, I can just get the steel man. It seems like beams of light act like rays, and beams of light split. And so when the R0 splits into R1 and R2.
Tell me this. Why do you think...
When do they split? What causes the ray to split?
Snell's law.
Cool. And that would be the light going from one medium, hitting a boundary of another medium at an angle, right? Like from air into water.
It's even more narrow than that. It's isotropic.
Yeah. But we were trying to discuss the light just passing through one medium where there is no boundary.
Wait, quick question.
Oh my, you do this all the time, dude.
No, go on. Sorry, I'm sorry. I'll be done.
I'm trying to be patient. It's like, this is where the whole conversation started about 20 minutes ago. What causes refraction, or as you're putting it, causes the light beam to split? Now, we've gone through Snell's law. We've gone through one isotropic medium where it hits the boundary layer of another isotropic medium and changes its angle. So where's that if we just have one medium, light passing through the atmosphere, for example? Where's the boundary layer?
Well, two questions. Are you aware of a law that governs anisotropic media?
No, you're going to answer mine.
I will.
Good. Can you do that now,
I can repeat
please?
your question back to you to make sure I didn't forget it.
Cool.
You're asking, your question was, why would light refract in the atmosphere?
Yeah, if it's not passing from one medium to another. And
I'll answer that, but sure, I'm just wondering, is there a law that governs anisotropic refraction?
Don't know, mate. I just want you to answer the fucking question because I'm starting to get impatient.
He's globing it up big time.
I mean, this was claim 20 minutes ago before we started going well off into the fucking weeds. I don't understand why you, a flat earther, would be.
Wait, to be clear, do you think that IOR of atmosphere is homogeneous?
Say that? What he thinks? He just answered his question. That would be easy, wouldn't it?
Well, what I'm telling you is that if the IOR in the atmosphere is not homogeneous, then you would expect refraction.
We've just gone through the definition of refraction, but now we're saying if the atmosphere.
Refraction is when you have. Go on.
Go on.
When you have changing IOR, right? Delta IOR induces refraction. So the question is there delta IOR in the atmosphere? Right?
Boring.
So to be clear, the thing that characterizes a media in the context of Snell's law is only its IOR, right? And so what induces refraction is a change in IOR. So the claim here is just, is there homogeneity in IOR in atmosphere?
How do you have an angle if there's no boundary?
How do you have an angle if there's no boundary? Well, I mean, if the IOR was 2 on the left, and what I'm telling you is that if the IOR is changing, there has to be. Yeah?
We went through this earlier. You brought it up, and you were very good to bring up law of reflections, right? We went through this.
Mm-hmm.
You need that boundary for the angle of incidence, the light passing from one medium to another and hitting that incident line at an angle, the boundary separation. Where'd you get the boundary separation in one medium? Where'd you get your angle?
Wherever if there's homogeneity in IOR, that means the IOR is changing, which means that at some points it's 1, say at one point it's 2, and at another point it's 3. That means that at some point it had to change, no?
I don't know, mate.
Do you disagree?
I don't know.
Because it seems like any change, any delta in IOR will induce refraction, right? And so the question is the IOR of the atmosphere completely the same? Is it completely homogeneous? Or is there variation?
No, it's inhomogeneous.
Wait, if the IOR is inhomogeneous in the atmosphere, then you would certainly expect refraction.
Hold on.
Hold on, I gotta grab some food. 1 second.
Yeah, the reason why Reed doesn't want to answer if he's a glober or a flat earther is because he doesn't want to be held accountable as a glober. So it's easier just to be a flat earther and ask a bunch of questions, so you don't hold him to any.
That's why I want to get exposed though, because he's autistically going on about light refraction as a glober, claiming he's a flat earther. So
yeah, he just doesn't want to be held accountable. That's all.
Like, why are you pretending, dude?
It's all the hormone.
Pretender clown.
Defend himself.
What up,
makes
Chris?
me confused is that someone said that saying that light can refract throughout one medium is a
the claim is that the claim is that any delta IOR induces refraction. The only case where there is no delta R in the atmosphere is if the IOR is completely consistent, if it's homogeneous. And so the claim here is there any variation in IOR in the atmosphere?
No, the question is, why have they lied to everyone, telling everyone that they're living on a spinning ball when they don't? Why do you think that is?
I'm not sure, actually.
You thought about that yet in your last 2 days? Has that occurred to you to think, well, now I know that they've lied to me. Why have they lied to me?
I don't think they lied, because I think lying presupposes an intention. I think they're just genuinely confused as well.
You think they accidentally photoshopped images?
Well, I mean, I think it trickles down from the top, right?
School kids.
I think it trickles down from the top.
Photoshopped Ball Earth images and made.
No, but like your third grade teacher isn't in on it. I don't think.
So NASA are accidentally telling us that they're going to a place where they can see a Ball Earth, even though they're
you said the person who taught you. That would be my third grade teacher. Did you perhaps mean NASA?
That's because that's where the information is claiming to come from, isn't it?
Well, you said who taught. You said the person that taught me. That was my third grade teacher. She wasn't in on it. Are you confused?
No, I didn't say she was in on it. You fool.
Well, you said she lied, but that would presuppose that she knew the truth.
No, I didn't.
But I don't think she did.
I'm saying this story is being propagated from the establishment.
No, what I'm saying is to lie, you have to knowingly misrepresent the truth.
Bro,
but if you have no knowledge of the truth, you're not lying.
Listen, pedantry is not a good debate tactic.
Well, you asked me, did she lie?
No, I'm asking, why are they...
If she didn't know the truth, she did not lie.
Answer the question. Why do you think they're promoting this worldview that you now say you don't think is true?
I'm actually not sure.
Well, what's your thoughts? You must have thought about it.
Why did you advocate?
It has to go way back. It has to go way back.
Yeah, why did you advocate for it?
What does that mean?
Find out why you lied and use that answer.
Yeah, why are you in here pretending like a fool?
I
think this is a good argument for the globe, a good look to say.
I don't think there are any good arguments for the globe. I mean, it's so eminently flat.
What's the claimed radius of the globe?
3590.
Close. Still a globe cut, though.
What is it?
It's right, you're really close.
Oh, I have dyslexia. I'm sorry.
So who measured that? Or who do they claim measured that?
I think they say the first person who measured it was like from ancient Greece.
Yeah, how did they do that?
They took 2 poles and then they measured the shadows, and then they did the trigonometry based on them measuring the distance on horseback between 2 cities. Yeah, so they were on 2 cities. I forget the names. But yeah,
what part were they?
Horseback.
Did they not time how long it took to travel, or am I crazy?
They timed how long it took to travel. What clocks did they use?
It's
they used the sun.
Hey gamer,
the
no
200
gamer.
BC
Look it up. It's really hilarious how they told you they mapped it out.
Do you know?
Yeah,
it was the length of a man's stride.
Yeah, a guy who was there was apparently a profession back then of people who were like trained to take the exact same step every time they.
That's so fun. That's even better. I'm sorry, I was confused. I thought they would just like time it, but that's even better.
Time it over what distance? What distance do you think they were measuring?
2 cities.
800 miles.
Yeah,
that's not a distance. What's the distance between the cities? Come on, man.
Well, I mean, I can give you an upper bound in that they were in Greece. I don't know the exact distance, though. Do you want me to look it up? Do some research?
No, well, you can, but
you would have already done this. So, because if you're saying you don't believe the globe, but you apparently haven't even looked at the most fundamental claim they make about it. Not really flat earther behavior. Most flat earthers, actually research the claims.
It'd be better just
do you put much stock in the possibility that this lack of apparent research is just because of the recency of the conversion?
It's better for you to just own up that you're a glober, so that we can all identify that.
Then there's no point.
If it was a genuine,
but you can see then
genuine thing. No, if it was a genuine curiosity or change in your perception, your questions would not be, what about the preservance of a ray of light through the atmo and its refraction possibilities? You'd be asking questions like, why have they done this?
Do you do you put any stock in the possibility that this perceived or apparent lack of education is more a function of the recency?
No, it's not about your lack of education.
Sorry, let me be more precise. Sure, I mean, I can be precise. Sure, no, I can be precise.
No, it's all right. I'll tell you what it is.
Okay, lack of knowledge.
No, it's not your lack of knowledge. A lack of knowledge would actually go in your favor. I mean, you do have a lack of knowledge, but it's your focus on anything.
Well, you said I didn't know. That speaks to a lack of knowledge, does it not?
Why are you interrupting me? It's the obvious attempt to avoid the topic that makes it obvious.
Hold on. 2 minutes ago, you said you don't know. That's not flat earther behavior. Doesn't that speak to a lack of knowledge?
Your lack of knowledge is telling of a glober, but it's your insistence on dwelling on something like the concept of a ray and its potential to refract in the air, when you don't even know the basics of Eratosthenes or haven't apparently even asked the question, well, why has someone lied to me? It makes it obvious that you're not critically and honestly engaging with the topic or the circumstance that you find yourself in.
Yeah, do you put much stock in the possibility that this perceived deficiency in critical thought is more a function of intelligence differences?
No, because it's clear that you're not a dumb person. That's
I'm not? You mean I'm smart? I'm gonna blush, gamer.
I'm not
a dumb person. That's the nicest thing anyone's ever told me. I'm gonna cry.
Well, yeah, your emotional instability is also telling of a global behavior of your generation. But it's not your ability to comprehend.
Yeah, you're ignorant. You're not dumb.
You think I'm good at comprehending and I'm not dumb? That's so sweet of you. Okay, well, do you put much stock in the possibility that it's because I'm like lacking in critical thought?
No, it's the fear in you because you won't engage with the topic because I guess you're scared of the possibility that you have been.
Well, I mean, that's one possibility, but there's another possibility. There's just this, lack of critical engagement for other reasons, namely a lack of intelligence. Why don't you put much stock in that?
Because we speak to hundreds of people, so we can tell how a person's feeling by the way they're conducting themselves in here.
Wait, but how much stock do you put in that possibility of this being caused by a lack of intelligence?
Very little at this point. No, it's more disingenuous.
Why? Wait, why?
Because it's obviously more disingenuousness than it is in a lack of intelligence on your part.
You say it's obvious, but why do you think? Are there any reasons that you believe that?
Yeah, because of the way you're
like what?
Approaching
it's an identity crisis. That's the reason why.
It's the way you're avoiding the big obvious questions and points to consider about this.
Wait, but how does an avoidance indicate not a lack of intelligence? Surely people who are less intelligent are more likely to dodge.
It's also the way that you're doing autism thing that you're repeatedly doing, where you're trying to dwell on my perception of your intelligence. I don't care about your intelligence. I'm talking.
Well, I think me being unintelligent would explain all the phenomena you're talking about, right? And do you put any stock in the? You said you put some stock in the possibility. It's not zero.
Dude, check this out.
Honesty.
Yeah, check this out, dude. If just the manner in which you're engaging right now, okay, you're doing like this little ping pong game, okay, and in all the while using above average terminology, over the last 10
the number minutes. Of syllables?
Yeah, many multisyllabic words, all this sorts of stuff. It's a sign of intelligence.
You think I'm smart? That's so sweet. Oh my god, I'm gonna blush.
Dude, I'm chatting with Crypto. You're not a dummy. You're just a fucking asshole.
I'm not a dummy. you're so nice, Mike. I love you.
No, but you're a fucking asshole. So that negates my prior statement because it's a net zero. Okay,
it's actually just cringe.
You're using an arrogant trick. Okay,
yeah, it's more cringe, you're not just dumb.
Bust up,
move
dude.
On. Just move on. Anyone else but him?
Yeah, there must be someone else. Someone you can have an honest conversation.
He's streaming this, by the way.
Good. Let him embarrass himself to a larger audience than he already is.
It answers the question why they would lie. You got in real time. People will lie for literally no reason whatsoever. They can't. They'll just lie just for the fuck of it.
Well, no, I see it. This is like a defense mechanism for some of these people. In some way, he thinks this is shielding him from the actual topic or the actual realization that he claims to have already had, which is that Earth isn't a spinning ball.
Yeah, so
the distractions and the nonsense.
Cyclone's going right for the jugular.
Well, because otherwise he's going to fucking rabbit on about refraction for 2 hours, gliding over the fact that the Earth isn't a ball and that as if that has no consequence to it. So yeah, it's just nonsense.
Yeah, he likes to be the center of attention every time he comes in here. That's true.
Absolutely. Absolutely. He's been doing that for the last 45 minutes. However, we do have new people in the channel. So if there's anybody new that's just joined us and you think it's weird that people in 2024 are saying the earth is flat and you want to have a discussion, please unmute yourself. Any questions, any thoughts, any feelings? We'd love to hear from them. Got a few new people, like I said. Can't even speak. Almost exactly. Welcome to the channel, my friend. Chibson, you're also new, I think. I've never heard of you before, but welcome to the channel. I'm not going to scroll down to everybody's in the name, but guys, if you've got any questions or anything, please unmute yourself. We want to get away from the last conversation because, my God, that hurt my head.
No,
And although Jedi
I would just say hello. Oh, sorry.
So, hello.
Oh, that's Flat Earth Egypt. He's kind of another one.
Not a newbie.
No, he's not a newbie. He's a bit discombobulated. He's akin to like some other individuals.
Whatever you say.
We
Oh, that's true, man.
Than feelings, but
hello, everyone.
Hello, my friend. How are you?
So I have a question.
What's your question, mate?
What was the first, what was the triggering event that made you believe that the Earth was flat? What tipped you over?
Realising that water laid horizontally over distance.
The solar eclipse 2017.
Flight check for me.
Okay, hold on. Go ahead. Sorry. So solar eclipse, water. What else?
Seeing the obvious evidence of NASA faking their videos, like photoshopping a globe Earth, green screens on the ISS, glitches, computer graphics and artifacts, showing that pretty much everything they're giving us is special effects.
Real physics that we demonstrate are
Long
the
distance
anti.
observations.
Right. And real physics of everything we demonstrate don't do anything that they claim. They cannot demonstrate in any physical attributes of what they claim.
Yeah, so my question is about the exact moment when you had the click, because like this is a major part
it's
of
different
your
for
belief
everybody.
system.
People just gave you
has
answers.
changed.
Like I said flight. Someone said physics. Someone said whatever. It's different for everybody. So
yeah,
it's called your flat smack.
There's not one specific answer, Uriel.
It's the flat smack, is what you call it. Like, so there's people who like when they saw, like one person I know, their flat smack was the astronauts telling them to drink or to swallow, telling kids to swallow their toothpaste. That's all it took. And that clicked. That was the flat smack. Another one was seeing Don Patet, because his idea in his mind was astronauts are the cream of the crop, the best of the best. And they saw this guy who barely put two words together. And they're like, there's no way that's an astronaut. I'm like, not only is he the astronaut, he's their spokesperson. He's the longest active astronaut ever. He's like in the Guinness Book of World Records. He's like supposedly the best of the best. You like when they made him, like when they made astronauts, they broke the mold, and this guy surpassed all expectations of what an astronaut could or can be. There'll never be another guy like him. And they're like, holy shit. Okay, you're fucking with me, Crit. That's a celebrity impersonator on YouTube. And I'm like, no, here's here's NASA's YouTube channel. Here's him playing with eggs, okay, on the ISS. He's playing Angry Birds on the ISS. And they're like, holy shit. And once that flat smack, you realize that these astronauts are some of the most dumbest, autistic people you can find. He's like, okay, that was it. That's all it took. So each person has their sort of sacred cow that they said, this is true if globe. And as soon as they see it's not true, therefore not globe.
But yeah, I think what you should take from that is that it's different for everyone, but there are some main points that tend to do it for people, and the lack of curvature demonstrated by long-distance observations and laser tests and other things.
Oh, I know the arguments. I was just curious about that very moment, right? When I had it under discussion with another gentleman, and he told me that it was when he saw too far, right? And I'm kind of trying to wrap my mind around what does it for people.
Well, what do you think about that argument that he sees too far? There's no curve. What's your thoughts on that?
So the idea was that he saw too far over the water, right? Yeah. So I did the math, and indeed it was too far. But again, I wouldn't know how much refraction would have had a hand in that, right?
Well, how would you? Why would you default to assuming that there's a potential answer from refraction? Like, what's given you that idea?
I'm not. It's that it's the fact that I do not have enough information to tell for sure that it wasn't a refraction. I know it exists and I know how it works. So it could have very well been at play.
But you don't know that it bends light around physical obstructions to make you see things that are physically hidden behind obstructions, right?
That is something that I know. I work with waves all the time.
Okay. So if you know that, then you know that refraction can't have lifted up this image from behind a physical curve and allowed your friend to see it. So refraction wouldn't even be a potential rebuttal if you know that.
Well, it could do that. I asked him.
You said it wouldn't do that.
No, I said it could do that.
You just said it wouldn't do that.
You must have misunderstood me.
You just misheard him. He said it couldn't do that. That's what he said.
Yeah, he said it couldn't bend light around a physical obstruction, allowing you to see something that's hidden behind a physical obstruction. That's what he agreed to.
No, I think it can, and I can't. What?
Oh, okay.
What
so
I
what
don't
evidence
know
do you
is
have
to what
that
extent it would do that, right?
Okay. Well, why do you think it can do that?
Because waves bend when they are meeting, when they are passing through materials of different densities.
You're talking about seeing something that's actually hidden behind a physical obstruction due to refraction. What makes you think that that's what refraction is? That's not what refraction is.
Because that's how waves bend.
What are you talking about?
What waves?
What are you talking about?
Any waves. So even water bends in the same way, or
does light bend around physical obstructions in air so that you can see things that are hidden behind obstructions?
It bends like if you have, for example, there was this device that I think the U.S. Army had in Second World War or something like that, where they had this ball, like this metal ball with a hollow core, and it was calculated in such a way that if you dropped it into the ocean, it would go to a certain depth, and then it would blow. And
what has that got to do with the shape of the Earth?
We're seeing things behind physical obstructions. That's got nothing to do with what we're talking about.
Yeah, light.
It does, because it's about waves.
No,
right?
no, you need to demonstrate. No, what you need to demonstrate is being able to see something that's physically obstructed by a physical obstruction, but you can see around that physical obstruction due to refraction. That's what you need to demonstrate.
Let me see.
Because you're basically saying that this image is below the curve, right? This land that the guy's seeing that's too far. It's physically below the curve, and you can't physically detect it if you had a line of sight from your eye. Yeah, so you're saying the light is bending around that curve, allowing him to see it.
Yes, and I proposed an experiment to him to make sure that that's what's happening.
Right, so how do you evidence your claim that that's even possible, that the light can bend around a physical obstruction, allowing you to see round a corner or a hill? What is your evidence? What have you seen in reality?
You can make an experiment.
Well, did you? Did someone?
I'm sure other people did. I've done it with other stuff, not with light.
Well, this is what you're claiming is occurring in the observation. So this is what you need to prove.
I can prove it. But
okay, could you post in the side chat the proof of it? Well, just post the demonstration.
I can prove it in the sense that I can run an experiment in which I can show it happening.
You saying, well, post it then. Post the experiment that shows it.
Okay, I'm not going to do that now, but
all right. Well, then that claim can be dismissed. Well, the claim can be dismissed if you don't have any evidence for the claim that you're making. The claim can be dismissed. Yeah.
So again, I can look for evidence right now, and like I said, this is a simple experiment that can be done by anyone.
You don't have to, but if you don't have the evidence, your argument will just be dismissed. And so the guy sees too far, and you've got no counter argument. Or you can post the experiment you're claiming, and we can look at it.
Okay, well, let me look it up. I'm sure there are plenty of experiments on the topic.
Okay, you look it up and give us a shout when you find it. Anyone else while he's searching for that? Questions? Comments?
Right. Hold on a second. You know how prisms work?
Sure.
Do you understand that that is how basically they prove diffraction?
Well, you'd be talking about light traveling.
Refraction.
Well, you'd be talking about light passing through the medium of air into the prism and then out again. That's not what's happening in the long distance observation.
It kind of does, except that you have a gradient of.
Except there's no prism. It's just air. So it's not air and prism and air. It's just air. So no, not the same.
Well, if you have the idea, it's about densities, right?
No, it's not about the idea. It's about your claim, which relates to the medium of air alone. So your demonstration can involve a prism as well.
Well, it's the same thing there. It's just that
no, air is not the same as a prism.
Brother, we got a really bad error on the table, friends. The reason why a prism works is because different wavelengths of light refract at different rates in the same media. So when they pass the boundary, they split up because they're refracting differently based on their individual wavelength. That's the reason. So this guy's attempt to tell you the reason was wrong. All right, keep going.
What?
Yeah, I mean, his reason for invoking it is inconsequential in my mind because it's not analogous to his claim, which is just air.
When I was talking
about Cyclone, what they're telling you is your claim includes two different media, yet you're attributing it to air, which is one medium, right? So your example that you're calling an experiment there is not analogous to the very thing you're trying to prove. Do you understand?
He's talking to you, not me. I don't know why he said Cyclone as if I'm the guy.
Oh shit! I apologize because you lit up. I thought he was talking. I didn't see the chat.
No, that's all right. Whatever. I don't know what the guy's name is though, because I'm not looking at my phone.
Yeah. So right now I'm trying to find an explanation for you. It's something that I'm going to say this though. I'm not going to use this as an argument, right? But I'm
no, but Uriel, can you respond? Like, do you understand what they're telling you?
Yeah, I understand. And I was just telling you that I'm thinking of a way in order to explain this.
Yeah, that's fine.
Right?
That's good. That's good.
I was also telling you that I'm not going to use this as an explanation, but I'm using this idea in my daily life, right? and it works. Math checks out.
Right, but that doesn't have any relation to the fact that we are seeing too far on a regular basis, every day, like you say, in our real lives, and there's no rebuttal to it if this refraction argument has no evidence to support it, which at the moment it doesn't.
Okay, so your argument is not that if refraction would work, then like your problem is that refraction doesn't work. Your problem is that you think refraction doesn't work if you have the same medium, correct?
No, well, that's Snell's law. It needs to go from one medium into another. But the argument from my side isn't specifically anything to do with refraction. It's the fact that there's a claim of a geometric curvature to the surface, which is not evident. It's not observed. It's not measured. It's not detected. So it's not there, right? And coming up with an excuse as to why it's not there and saying possibly refraction, but having no other evidence to support that isn't a rebuttal. It just leaves us with, we've got no curvature.
Okay, so if I prove the refraction to you, would you still say that that's not a good argument? Because
my contention
I haven't
isn't
contributed in
refraction.
that.
No. What you need to evidence is the curvature itself. That's what's in contention. Because when we see too far, that's not evidence of curvature. It's evidence of a lack of curvature. And if there's no rebuttal to that,
so then your problem is that I'm starting from the assumption that the Earth is round and not flat.
Yeah, yes, and you're looking for a way to make that possible on a round Earth, a glober, that you currently don't have any evidence for, and you're actually trying to rebut very strong evidence against by invoking the thing that you don't have the evidence for, right? So, and then coming up with an idea, a concept about how the light is behaving, again based on no evidence, just to try and make this work on a ball that we have no evidence for. That's a problem. Fallacious logic. You understand?
I'm thinking about it, but yeah, I understand.
Yeah, well, that's good. I wouldn't ask anything more. Think about it. And if you find what you think is a compelling demonstration of the type of refraction you were claiming, then post it in the chat and people will check it out.
So for myself, I'm absolutely certain that that kind of refraction exists and it's possible.
Why would you be absolutely certain though? Because I've just asked you what's made you believe that, and you can't even come up with a demonstration that you think you've seen. So you can't be absolutely certain that that's real because you've never even seen a claimed demonstration of it.
We are talking about two different things. About refraction, I'm absolutely certain that it exists and it would work, right? But about the spherical Earth, right? You're asking me to prove that or to come up with an example that it's spherical without the refraction thing.
Refraction.
Refraction.
You've got it mixed up again. I've been very specific about my contention with your refraction claim, and that is specifically the claim that the light is bending around an obstruction, allowing you to see something that's physically obstructed. That was specifically the contention with refraction. We're not denying that there's a word called refraction.
I have no doubt that that is possible, right? I cannot prove it to you right now.
I'm challenging that because you don't have any reason to claim that it's true. So you can't possibly be certain of it because we've asked you for the evidence of it and you don't.
Earlier you said that this is not your contention point. Your contention point was that I'm starting from the idea that the Earth is round and that's why I'm going to.
Well, yeah, it's part of the same claim because the claim that you're assuming about refraction and that you're making about refraction assumes the globe. its
No,
in its
no,
premise.
it doesn't. It doesn't. It doesn't.
Yes, it does.
That's
Yes,
something
it does.
independent of the
It
globe.
does because you're saying the light is bending around the curve. The curve of what?
I'm saying it's possible, right? Because refraction works that way.
No. Again, see, you've just said refraction works that way. You're assuming the globe in the bending of the light around the curve, which you don't know, for starters.
If it was okay, let me rephrase then. If it was a globe, right, and we looked across the water, then refraction could allow us to see further than we should geometrically see, right?
But saying it's not what you're saying, if it's a globe, is useless. What if it's not a globe? Then we wouldn't have the curvature obstructing our view, which we don't. So I could just say that. I could say, well, what if it's flat then? You would still be in the position where you have to provide evidence for your claim that it's actually this ball you're assuming in your refraction claim.
Well, in this case, it would actually be very simple to figure out what's happening. In this case, we would only need to know. In this case, we would only need to know if what we're actually observing is the effect of refraction or not. If we have a lot of refraction, then we are seeing further than we should, right? And we should be able to calculate the curvature of the Earth from that alone, right? Just by knowing the refraction index. But
you don't know
if
the
it's not
refraction
refraction, let me finish. If it's not refraction, then it's flat, right? So if the refraction is 0, then it would be flat. So my experiment, the experiment I proposed to this person, was to see if to check if what he's seeing has all the colors, right?
No, see, this is where you're getting confused. This is where you're getting confused because you're trying to hinge the crux of the debate, flat Earth or globe Earth. You're trying to hang that on this argument about refraction, where you invoke your imagined concept about how light can bend. Rather than focusing on the actual crux, rather than focusing on the actual crux, which is the physical surface of the Earth and whether it curves or not.
Okay, so first of all, refraction is not imagined and it works with gradients of density.
But you're talking about curving light around a ball so that you can see the part of the ball that's actually hidden behind the curve. That's not refraction. That's something that's just been made up.
Not made up, it's something you can test yourself.
Okay, define the type of your refraction that you're invoking. What's its name?
Refraction.
No, there's multiple types of refraction. What one are you claiming?
I'm not sure what you're talking about. Like which of
the
types?
See, then this is the case. You're obsessing over refraction, and you don't even know that there's multiple kinds or what kind you're supposedly invoking. So it's useless to even have this discussion.
What types do I have to choose? What type? Like, give me the types.
No, it's not my argument. If you want to make your argument, know it.
I obviously don't know what types of refraction you're
So you should probably go away and figure out what
then.
they are, and then come back and have this conversation.
Yeah, I mean,
I know what refraction is extremely well, right? Because, like I said, I'm using it.
Well, define it.
I don't know what. I'm sorry.
Give us the definition. Give us the definition that you're using. Define it.
I'm not using a definition. I'm using the fact that
you have to be using a definition. It's your argument. Your whole argument is about refraction. You have to be giving it some definition.
I'm not a teacher, man. I don't know this stuff.
Well, then why are you claiming this argument?
He just said he knows it. You just said you know it very well, dude. Now you're not a teacher.
Yes, I know how it works. I know how it works. I know.
That's what he's asking you, stupid.
Define it. Define how it works.
No, how it works? Well, the idea is that when a wave, it's a different density material, like waves are propagating in something, right? In water, in the electromagnetic field, in whatever, right? When they are hitting something that is higher density, they're going to slow down. So if they're hitting it with only one side of the wave, like let's say the half of the wave first hits this higher density material, it's going to slow down, right? So in doing that, as the other part of the wave is reaching the higher density material, it's basically bending down towards the higher density material. Let's say that it's at the bottom, right? And it's the opposite effect when you have higher density materials. And that's all that happens, right?
Okay, so could you, just to make it succinct, could you post a definition from, I don't know, a university, a dictionary, and a demonstration of that claim that you just made?
Okay, I can look it up, I guess.
Yeah, show us
probably,
how.
since it's your argument, apparently.
Yeah, and show us how there's two mediums that you're looking horizontally straight through at the boat.
Yeah, and
so, like, what's the end game
of what?
Of the world being flat?
So, what do you mean?
What's the end game? What does anybody benefit?
The Earth. What does anybody benefit in telling you what your reality is and having you believe them? You can't work that out.
Well, okay. Like, let's say that the Earth is flat. Okay, what are they hiding? What are they hiding from us?
The Earth, creation, where you think you are.
I posted the link, man. And if you scroll down, the fourth figure is actually exactly what I was trying to describe. I hope I was close. But that's pretty much how refraction works, and it works even if the medium is like the medium changes a gradient, and it's not like such a big change.
Yeah, nothing here says that light can bend around an obstruction and allow you to see.
Do you see how it changes? Do you see how it changes direction?
Those are through different media, not through air, and they're not bending around an obstruction. They're changing their angle when they pass through a different media.
Right, and if you have a gradient,
that's not analogous to when you're looking across a lake or a body of water.
If you have a gradient around a ball, it's going to you can have that
you
angle
don't
to
have
actually.
A ball. You don't have a ball, and nothing in this says that. What you've just said.
If you did, right?
No, but
if you did have a ball.
No, but you would need to evidence that.
Evidence what?
A ball.
Well, I don't care about the Earth being round for this argument, right? We could have a different ball.
That's what the whole argument
is. I don't, because we have two different arguments here. One is about refraction being able to bend, and we don't need a globe for that to happen.
Your argument assumes the ball because you used it in relation to your friend.
I do not care about the ball, this particular argument.
You do, because you invoked this in response to your friend seeing too far, because you are claiming it's a ball.
I'm telling you that I do not for this argument. That is the other argument. The current argument is whether light can bend around something.
Okay, so you're not arguing that the Earth is a ball.
Not right now.
Okay, I agree. It's flat. Okay, so your friend's seeing too far, or your friend's seeing a certain distance over a flat surface. What's the problem with that?
No, you're jumping to a different argument. Now we are talking whether light can bend around something or not.
No. I don't care how you think light bends over a flat surface. If you agree it's flat, I'm fine with that.
But I don't agree with that either. You disagree that refraction can cause light to bend around an object. And I'm trying to prove to you that it can.
You're saying it's bending around the curve to let your friend see too far. That's why.
Okay, so then Are we at that point in the conversation where we are past refraction being able to bend over a circular thing or not?
Well, yeah, because you said you're not arguing it's a ball anymore.
Well, that's because you wanted to move the discussion
No,
from
no, no. I was
refraction
always
back
talking about it.
the.
Yeah, no, I was talking about that in relation to the claim that it's a ball, not in abstraction.
Well, before we get back to that, we have to clarify refraction.
Well, we just did. You went through your page and it didn't say what you said refraction was in terms of going around a physical obstruction and allowing you to see it in air. That's not what the Wikipedia page says.
So we can discuss that, right?
Well, what's there to discuss? We asked you for evidence of that claim 20 minutes ago, and you still haven't given us any, so there's nothing to discuss.
It gave you evidence that...
Anyway, I need to go on mute, so who's in here from the Flat Earth side that wants to pick this up? Come on. I know you guys are raring to go. I normally can't shut you up. DJ, you there? AI?
Yeah, I'm just about to head to bed. Sorry, mate. I'm in Europe too.